3, Lesson 20, we're going to look at composite area problems. And so in our first problem, they're asking us to find the composite area of the shaded region. The shaded area. And we're going to use 3.14 for pi. All right. First thing we ought to notice is, obviously, we're looking at circles. There is a larger circle, and then there is a smaller circle that is cut out of the larger circle. So what we want to do is find the area of the larger circle, find the area of the smaller circle that's cut out, and subtract them. Our larger circle will be, the large circle has a diameter of 6. And on the coordinate plane, I know that because this side is on 2, 5, and this side is on 8, 5. And the difference between 2, 5 and 8, 5 is 6 units. So its diameter is 6. The small circle its diameter and again I'll look at the coordinates. It's 3, 5 and it ends at 7, 5. So its diameter is 4. Now with those measurements then, we find the area, which is radius squared times pi. So radius squared, which is half of the diameter, would be 3 squared times pi, which we're going to do by approximating 3.14. And then our calculation, 9 times 3.14 is 28 and 26 hundredths. And these are square units. For our small circle, the diameter is 4. So our radius is 2. It has to be squared times 3.14. And 4 times 3.14 is 12 and 56 hundredths square units. And so for the shaded region, we subtract 28 and we find that shaded region to be 15 and 7/10 square units. In exercise 1, there is a yard with a shaded section including grassy areas and the unshaded sections indicating buildings or paved areas. We need to find the area of the space that's covered with grass in square units. Obviously, because we may be treating the grass or we may be planting the grass. There are lots of things that you do with grass, and the price is based on how much square footage you have or square yardage, whatever your unit is. So again, the clear spaces are paved or buildings, and the shaded spaces are grass. In order to find those areas, first of all, we do have a rectangular area for the grass. So we can find the area of the rectangle first, and then we can find the area of this building inside and subtract it. So our calculations, rectangle ABCD is 3 units by 2 units. 3 times 2 equals 6. And rectangle IJKL is 1 whole unit, right? There's half here and half there, by 1/2 unit, which is 1/2 square units. And we subtract them. 6 minus 1/2 is 5 1/2 square units. Example 2, we're asked to find the area of a figure which consists of a rectangle with a semicircle on top. And we'll need to use 3.14 for pi. So the first thing we need to determine then is where this semicircle begins and where the rectangle ends. So we're going to draw a line showing that space. And even though at this point you may wonder how on earth we're going to find this measurement, there really is a way to find that. First of all, this is 4. And we know then that the diameter of the circle is equal to 4. Very important point. We also know then that the radius, which is half of the diameter, is 2. Again, very important point. Because we know this is a semicircle, we know that from this location, the center of the circle, to the outside of the circle is 2. Again, from the center of the circle to the outside of the circle is 2. So that means if the entire height is 7.5 meters, we would subtract 2, and that would be the height of our rectangle. So 7.5 minus 2 is 5.5, and our rectangle then is 2 times 4. I'm sorry, is 5.5 times 4. 5.5, because that's 7.5 minus 2, times 4 across. And the area then of our rectangle is 22 square units. And the area of our semicircle is 1/2 times radius squared. And our radius, remember, is 2. So 2 squared is 4 times pi, which is 3.14 in this case. And so what we have is 2 times 3.14, which is 6 28/100 units squared. And altogether then, would be 28 28/100 square units. In exercise 2, we have another very unique shape. We're asked to find the area of the shaded region using pi approximately equal to 3.14. And what we have is a triangle. It is conveniently a right triangle. And we have a semicircle. So our triangle, remember the formula for triangle is 1/2 times the base, which is 14, times the height. Okay, our height then is the question. But our height is the diameter of the circle. The diameter of this circle, if our radius is 4, remember the radius from the center to the outside of the circle is 4. They gave us that measurement. So our diameter is 8. And when we do that calculation, we find that that is 56. And these are not units, these are centimeters. We use units when we don't know what type of units they are. Otherwise, we use the actual units listed. So our triangle then is 56 square centimeters, and our semicircle, which is 1/2 times radius squared, and our radius, remember, is 4, so that is 16 times 3.14, and that is 25 12/100 square centimeters. And so altogether, we have 81 12/100 square centimeters. And remember, this is approximately because we have to approximate with pi on our circle. Example 3 asks us to find the area of the shaded region. And they're saying that we should redraw the figure separately, separating the triangles, and then label the lengths, discussing the calculations. Hopefully you recognize this problem from lesson 19, where we had something rather similar. We had a triangle that was inscribed inside a rectangle. So what we're going to do is find the area of the whole rectangle, which is 20 by 20. So this particular rectangle is a square. And 20 times 20 is 400 square centimeters. And then we will need to find the area of each triangle. I'm going to go ahead and label them 1, 2, 3, so we know what we're talking about. Triangle 1 is 20. And the measurement of this base of the triangle we can find out even though it's not labeled. The whole length of this side is 20, and this section is 8. So if we subtract 20 minus 8, we'll find that this one is 12. So triangle 1 is going to be 1/2 times 20 times 12, which is on 120 square centimeters. Triangle 2, it's this one up here. It has a base of 20, and its height, again, is something that we'll have to calculate. This side also is 20, and the bottom part is 6, so 20 minus 6 is 14. And 1/2 times 20 times 14 is 140 square centimeters. And then finally, triangle 3 will be 1/2 times, and they gave us both measurements, 6 times 8, which is 24 square centimeters. And then for our final calculation, we'll take the area of the square, subtract each of the triangles, and we find that the shaded area is 116 square centimeters. In our final exercise, they're asking us to find the area of the shaded region, and this one is a little more complicated than what we've been looking at. We have this square and a larger square. We know they're squares because their sides have the same measurements. And then we have a triangle shaded inside this, and a triangle shaded inside this. So the first thing we want to do is let's go ahead and find the area of each square. We'll have the small squares, which is 2 times 2. It's 4 square centimeters. And the large square, 3 times 3, which is 9 square centimeters. And now we need to look at the other parts. Now at this point, we could be stuck. So we look at this shaded triangle. We know that it's 2 for its base. We don't know how high it is. There's no information that will help us get there. And if we look at this triangle, it's not even a right triangle. So there is no height that will help us find that measurement at all. I do see that I can find the area of this large right triangle. So we can do that first. Let's label that. We'll call this one 1. And then we'll hold off on the other one. Triangle 1 is 1/2 times 3 times 3. So that is 4.5 square centimeters. We know this space, and now we're looking at, and although I can see this is a triangle, I have no way of knowing what the height is. So this isn't going to help. And I can see this is a trapezoid, but again, I don't know the measurement of this second parallel side, so I can't find the area of this trapezoid since I don't have this measurement. When you get stuck like this, it's good to step away or to look further back and see if there is some other shape that you're missing. And in this case, I see that there is a large triangle being formed by the parts of the 2 squares together. And this large triangle has a height of 2 and a base of 5. And so we'll find the area of this large triangle, which we'll now label as triangle 2. And I'm going to write the 2 right in the center of the large triangle so that hopefully we remember we are actually talking about the larger triangle, not this small one. And so triangle 2 is 1/2 times 2, which is our height, times 5. And that is 5 square centimeters. Finally, we take our two squares, add those areas together, and subtract the areas of the two unshaded triangles. And that will give us 3.5 square centimeters for the shaded area.